Hi, in this video we are going to solve question number 42 of GATE 2013 physics paper. The question is from mathematical physics eigenvalue problem. So the question is the degenerate eigenvalue of the matrix 4 minus 1 minus 1 minus 4 4 minus 1 minus 1 minus 1 4, which is a 3 cross 3 matrix, and we have been asked to find its eigenvalues. By degenerate, it means that when we solve a matrix, we get independent solutions. For example, this is a 3 cross 3 matrix, so we'll get 3 eigenvalues, and corresponding to each eigenvalue, we will have 3 eigenvectors which are mutually orthogonal to each other. Now, if more than 2 linearly independent eigenvectors, if they have same eigenvalues, then those eigenvalues are called degenerate eigenvalues. Now, first of all, for solving this question, we may write the eigenvalue equation. Ax is equal to lambda x, where your A is your n cross n matrix, square matrix. X is n cross 1 column vector. And lambda is some scalar. So this eigenvalue equation actually represents some kind of linear transformation of X. So we can also write this eigenvalue equation as A minus lambda I x equal to 0, where I is some identity matrix. Here it will be 3 cross 3 identity matrix. Now, one of the special property of this eigenvalue equation is that this matrix A minus lambda is singular. That is, inverse doesn't exist. And in order to have non-trivial solutions for this singular matrix, we know that determinant is always 0. Determinant of A minus lambda I will be 0. Therefore, using this property of singular matrix, we can just, having a non-trivial solutions, we can just find out the eigenvalues. So what we'll do is that we'll compute A minus lambda I, determinant of A minus lambda I, which is, so determinant of A minus lambda I we have to find out. Now we know that we can write it as, we know A is 4 minus 1 minus 1 minus 1 minus 1 minus 1 4 minus 1 and minus 1 minus 1 minus 1 minus 1 4. This is A minus lambda times I. I is identity matrix, so it will be, lambda is a constant, so it is absorbed into the matrix, identity matrix. So A minus lambda I will be, determinant of A minus lambda I will be 4 minus lambda minus 1 minus 1 minus 1 4 minus lambda minus 1 minus 1 minus 1 4 minus lambda. So this determinant should be equal to 0. So determinant should be equal to 0. So we can just solve it. You can write 4 minus lambda times 4 minus lambda whole square minus 1 plus 1 lambda minus 4 minus of 1 minus of 1 1 plus 4 minus lambda. This is how we compute determinant. Now we'll just open this thing. 16 plus a square plus b square minus 2ab, 16 plus lambda square minus 8 lambda minus 1 plus lambda minus 5, and this can also be written as 5 minus lambda. So this can also be written as lambda minus 5 if we just take minus sign inside. So we are left with equation four minus lambda, in bracket we'll have lambda square minus 8 lambda plus 15 plus 2 times lambda minus 5 is equal to 0, which can be further written as, we can factorize this thing in square bracket and it will come out to be lambda minus 3 lambda minus 5, so that it becomes lambda square minus 8 lambda plus 15 plus 2 lambda minus 5 is equal to 0. Now we can take lambda minus 5 common, and inside the bracket we'll get 4 minus lambda minus 3 plus lambda minus 5 is equal to 0. Now when we solve this thing inside the bracket, what we'll get is lambda minus 5 lambda minus 5 again and lambda minus 2. This is just, you'll just open this thing and solve this, so we'll get this equation, and therefore the solution, 3 independent solution or 3 eigenvalues which we'll get here are lambda 1 2 3 are 5 comma 5 comma 2. So we've got 3 eigenvalues of this 3 cross 3 matrix A, and therefore we can just write that and we have to find the degenerate eigenvalue of this matrix. So degenerate eigenvalue is what? 5, because this is repetitive, this is occurring to, so for 2 corresponding to each eigenvalue we will have an eigenvector, so it means that 2 of the eigenvectors have the same eigenvalues, so 5 is the degenerate eigenvalue. This is the answer which you have to write here. Now there is another shortcut method which you can use to find the answer of this question. We know that first property is that sum of eigenvalues of a matrix is equal to trace of the matrix. Trace of the matrix. Here we have a matrix, and which is nothing, trace is nothing but sum of the diagonal elements. Diagonal elements of matrix A. The second property is that product of eigenvalues of some matrix A is equal to determinant of that matrix. So we use these two properties, and we can find the answer in shorter time. So we know that matrix A is, writing it again, 4 minus 1 minus 1 minus 1 4 minus 1 and minus 1 minus 1 4. So sum of eigenvalues will be trace, and trace is nothing but the sum of the diagonal elements, so it is 4 plus 4 plus 4, 12. Therefore lambda 1 plus lambda 2 plus lambda 3 eigenvalues, the sum will be 12. This is first equation. And product of eigenvalues is the determinant of the matrix, and we just find the determinants of matrix A. It will come out to be something like 4 times 16 minus 1 plus 1 minus 4 minus 1 minus 1 1 plus 4, so it will come out to be 60 minus 5 minus 5, so which is 50. Now I just factorize 50, so what you will get, this is nothing but lambda 1 lambda 2 lambda 3 product, 225 5 further 25 5 5. So yeah, so lambda 1 lambda 2 lambda 3 comes out to be 255, as it satisfies both this equation as well as 5 plus 5 plus 2 will give 12. So in this way we can easily solve this question in short time. So that's it. Thank you for watching this video. bye.